Hello everyone, welcome to Physics Unwrapped YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination. In today's video, I am going to solve previous year question paper related to Lagrangian and Hamiltonian formulation which was asked in KSET. I covered 2024 question paper, 23 question paper, 20 question paper as well as 2018 question paper. Okay, let us start with first question. Identify the correct Hamilton's equation of motion from the following. See, this is a very direct question and we have in the previous video I have told equation of motion for Hamiltonian is nothing but qi dot. This is a generalized velocity can be written as partial derivative of h with respect to momentum, and pi dot can be written as negative of partial derivative of h with respect to generalized coordinate. So option C is the right answer. Let us go to the next question. The Hamilton's canonical equation of motion in terms of Poisson bracket. In terms of, this is also very direct question. In terms of Poisson bracket, the Hamilton's equation of motion, which is nothing but option A, that is q dot, which is nothing but Poisson bracket of q comma h, and p dot is nothing but Poisson bracket of p and h. Okay, let us go for next question. The Hamilton corresponding to the Lagrangian is, they have given the Lagrangian and the Lagrangian is ax dot square plus by dot square minus axy. So to find the Hamiltonian, we have formula summation over pi qi dot minus Lagrange. My Hamiltonian is summation of pi qi dot minus Lagrangian. So Hamiltonian will be px into x dot plus py into y dot minus my Lagrangian is ax dot square plus by dot square minus axy. We need to substitute for px and py. As I told in my previous video, px is nothing but derivative, partial derivative of L with respect to x dot. So, differentiate L partially with respect to x dot means x remains constant here. So, if I do partial derivative, it will be 2 times of a x dot. Py similarly, dou L divided by dou by dot, it will be, we need to differentiate this Lagrangian, it will be b into 2 times of y dot. So I get the answer to be 2b y dot. On substituting in h, we get px is 2 times of x dot into x dot, it will be x dot square plus py is nothing but 2 times of by dot into y dot, it will be y dot square minus of ax dot square minus by dot square, minus of minus, it will be plus axy. So my Hamiltonian is nothing but, we will subtract the like terms. 2 minus 1, it is ax dot square, 2by dot square minus by dot square, we will get plus by dot square plus k times of xy. We know that Hamiltonian will be in terms of momentum. So we need to represent x dot in terms of momentum. See, from here I can write my x dot to be px over 2a. From here I can write my y dot to be py divided by 2b. So I'll substitute here, I'll get my final result. Instead of x dot, px divided by 2a whole square plus b into y dot is py divided by 2b whole square plus k times of xy On solving, we will get px square 4 times of a square. A get cancels. It will be 4 times of a plus py square divided by 4 times of b plus axy. So this answer matches with the option C. So my C is the right option. We shall go for next question. And the next question says, the Lagrangian of particle moving in a plane under the influence of central potential is given by, they have given Lagrangian in terms of kinetic energy minus potential energy. We need to find the generalized momentum corresponding to r and theta. Corresponding to r and theta, we need to find the generalized coordinate. Okay, momentum corresponding to r is nothing but dou L divided by dou r dot, and the momentum corresponding to theta is nothing but, according to the definition, dou L divided by dou theta dot. So I am substituting the Lagrangian and differentiating partially with respect to r dot, we will get a PR, and differentiating partially with respect to theta dot, we will get momentum corresponding to theta. So on differentiating partially, I'll get half of the m r dot square. On differentiating, we will get 2 times of r dot. Here we don't have r dot term, rest of the terms will be 0. So 2 get cancels, it will be m r dot. Next, p theta. P theta is, we need to differentiate with respect to theta dot, no. So half m will remain outside, and in the first term we have r theta dot square, so there is a no dependence of theta dot. In the second term we have a theta dot dependence. Here r remains a constant because it is a partial derivative. So theta dot square is nothing but 2 times of theta dot. 2 get cancelled, so my answer will be m r square theta dot. This is the final solution for p theta, and mr dot is the final solution for momentum along the coordinate r. So mr dot and mr square theta dot, my first option is the right option. Okay, let us go for next question. The Lagrangian of the system is given by, they have given the Lagrangian. We need to find the motion of the system, we need to find. They have given the options, they have given it as a harmonic oscillator, it is a damped harmonic oscillator, it is an anharmonic oscillator, or the system with unbounded motion. Okay, let us see which motion it describes. So my Lagrangian, they have given to be half of the q dot square plus q dot minus half of the q square. So we have the Lagrange equation of motion to be d divided by d dot dou L divided by dou q dot, that is a partial derivative of Lagrangian with respect to q dot, minus partial derivative of Lagrangian with respect to q, it will be 0. So on substituting, this is a complete total derivative, and partial derivative of L with respect to q dot, it will be 2 divided by 2 q dot. In the first term also we have q dot, and here partial derivative is q constant. Partial derivative of q dot is 1. So I am closing the bracket, minus dou L divided by dou q dot, dou q. So we have two terms representing q. So first term is q dot. Q dot, here it is constant. Partial derivative of q is 1 minus half of the partial derivative of q square is 2 times of q. My RHS is 0. 2 get cancels. Here 2 get cancels. So total derivative of q dot plus q minus q dot, minus of minus, it will be plus q, which is equal to 0, which implies So we need to do complete derivative with respect to q dot. If I do complete derivative with respect to time q dot, my gives q double dot. For q, we will get q dot minus the rest of the terms. I'll rewrite like as it is, q dot plus q, which is nothing but 0, plus q dot minus q dot get cancels. So my result will be q double dot, which is nothing but minus of q. In the previous session, I have given the dynamics and relative to the equation of motion. So q double dot, which is nothing but minus of q, this represents simple harmonic oscillator. This represents the simple harmonic oscillator, where C, actually the equation is given by minus C Q. Here C, my C is 1. So the C should be, the constant should be greater than 0. This Q double dot minus CQ represents harmonic oscillator. So option A is right. This I have given the theory to this question in the previous video. You can see my previous video. Okay. Coming to the next question. If the Lagrangian of the system is given by this, the equation of the motion we need to find. They have given the Lagrangian and we need to find the equation of motion. How we can find? We can find using the Lagrange equation of motion. So the Lagrange equation of motion is total derivative of partial derivative of dou L with respect to q dot minus partial derivative of Lagrangian with respect to q, which is nothing but 0. So substituting for L, and we need to do partial derivative with respect to q dot. So it will be half of the q square. Q dot square, if we want to do partial derivative, it will be 2q dot minus q to the power of 4. It is not depending on q dot. So constant here, it is considered to be constant, it is 0. Okay. Minus of Lagrangian, we need to differentiate Lagrangian partial derivative with respect to q. So we have two terms here, q square and q to the power of 4 along with q dot square. So it will be half of the differentiate of q square is 2 times of q. Q dot square remains same. Here it is a constant, minus of 4 times of q to the power of 3. It will be 0. So 2 get cancels. Total derivative of q square q dot minus half get cancels. Remaining is q dot square, minus of minus, it will be plus 4 times of q cube. It will be 0. So we need to apply here UV rule because it is a total derivative. My q is also variable, q dot is also variable. So first I will keep q square constant. If I do a derivative with respect to q dot, it will be q double dot. If I do derivative with respect to q square, it will be 2q dot. If I do derivative with respect to q dot will be my constant, minus of q dot square. Rest of the terms I am copying as it is. So on rearranging the terms, I will get q square q double dot plus 2 times of q dot square minus q dot square plus 4 times of q cube. It will be 0. So I can subtract my like terms. So q square q double dot plus 2 minus 1 is 1, q dot square plus 4 times of q cube, which is nothing but 0. I'll divide my entire equation by q. So I'll get q double dot into q plus q dot square plus 4 times of q square is nothing but 0. This is my equation of motion, required equation of motion. Which option matches here? Option A matches here. Okay. So my option A is the right answer. Okay. Let us go to next question. The Lagrangian equation of motion will remain unchanged if the Lagrangian L is replaced by L plus L prime, where L prime is a total time derivative of a function. So this is also kind of a direct question, I can say. They have replaced Lagrangian by L plus L prime. They have said this L prime is a function of what? Function of what? So that the equation of motion will remain unchanged. So if the function is, they have given the options: generalized coordinates and velocity and time, generalized velocity or generalized coordinate and time. I will say option D is the right answer. If my function is depending on generalized coordinate, that is q and time, means my Lagrangian, that is Lagrangian L prime, will not change equation of motion, means my equation of motion remains same for both the Lagrangian. So it is a function of x comma t. My L prime is a function of x comma t. Okay. Let us go to the next question. This is also a kind of a direct question, I can say. Nothing more to solve here. Lagrangian equation of motion they have given. This Lagrangian equation of motion, as we know that, are applicable to. It is applicable to which kind of a system they are asking. It is a conservative or a holonomic system, non-conservative or holonomic system, conservative, non-holonomic system, non-conservative, non-holonomic system. So option A is right here. It is applicable to conservative system as well as holonomic system. Thank you.